This video is about the domain of a function and specifically using interval notation. Okay, the domain of a function is all the x values of that function. All functions want to have a domain of all real numbers, okay? Meaning that it goes on forever in both left and right directions. They want to be like that, and they all tend to be like that, except for some special cases that we'll talk about in a minute. But I want you to know how to make the notation. Okay, all real numbers can be notated in two ways. You have been taught previously about set notation, and it would look like this. It would say the domain x is all real numbers. Okay, you may have seen this, and that's fine. We are not going to use set notation in this class. We're going to use what's called interval notation, and I think it's a little simpler because you don't have to remember all the symbols. Okay, what you do need to know is that in this case, like a graph like this, it goes on forever and ever and ever in the left-hand direction. That would be going on to negative infinity, because the x values are more and more negative the further left you go. This goes all the way to the right. Your x values continue getting higher and higher, so that goes to positive infinity. All right, so that being said, when we do interval notation, in this case, all real numbers would look like this. Parentheses, negative infinity to positive infinity. Okay, we use parentheses because infinity is not a definite ending. You can't tell me exactly where infinity ends, nor can you on either the negative or the positive end of that. So we use the boundaries with parentheses. You'll see a bracket further on when we have actual numbers here. You'll see how to use that in a moment. But both of these notations mean all real numbers. But the interval notation is the one I want you to use in this class. So please make sure and ask questions if you're not clear on what that means. So the domain of a function wants to be all real numbers. Now, there are two limitations to domain. Okay, two ways it can be limited. One is if it's in a radical. That means the x value in the function is under a radical. And this is a limitation because that x cannot be negative. Okay, when we're dealing with the domain, we're not going to deal with complex numbers or I or any of that. We want to keep whatever's underneath that radical positive. So that limits where our function may exist. So x cannot be negative. The other place that limits the domain is if x is an irrational function, meaning it's in a fraction and x is in the denominator. All right, x is in the denominator of a fraction because we do not want to end up, we're avoiding this scenario, which means undefined. Okay, we don't want our function to be undefined, so that will limit our domain. Here we're avoiding a negative under the radical. Here we're avoiding a 0 in the denominator. Okay, so these two things will limit the domain on a graph. It'll cut it off. So I'm going to show you what this looks like in example. Okay, first of all, let's start with this example. All right, the question is, what's the domain of the function? Well, let's look at this. When you approach a problem, you first ask yourself, is x under a radical? In this case, no, x is not under a radical. Second question you ask yourself, is x in the denominator? Okay, if I can answer no to this one as well, that means my answer is all real numbers. Okay, so we're not, in words, it would be all real numbers. But we're not going to leave our answer like this. You're going to write it in interval notation. So again, that means parentheses, negative infinity, comma, positive infinity, close parentheses. This is the domain. We do put a D because we will use range in the future. The domain is negative infinity to positive infinity, which means all real numbers. I can put that as my answer when I can answer no to both of these questions. So let's look at number 2. Is x underneath the radical? Yes, it is under a radical. So now we have to decide, we have to limit it. Okay? The question is, we don't want what's underneath the radical to be negative. So what is x plus 5, whatever that turns out to be, has to be greater than or equal to 0. If it's less than 0, then it's negative. I want it greater than or equal to. If it's a 0 under the radical, that's okay. We just can't have a negative. So what you do is you set up this inequality. X plus 5 is greater than or equal to 0. And then we solve this. If you remember, it's just like solving a regular equation. We subtract 5 from both sides. So x is greater than or equal to a negative 5. Now, you are going to be asked to graph this because it helps you develop the interval notation. Okay, so I put a number line. And here's where negative 5 is. All right, if you recall when it came to graphing on number lines, if it has an or equal to sign underneath it, that means you're going to have a closed circle. Okay, so on my graph here, I'm going to have a closed circle. And then I'm going to show which direction is it going. Is x going to be less than negative 5 or greater than? Well, it's going to be greater than. So I color this direction. I think darken that way. Now in interval notation, we have to show that x cannot be less than negative 5, but it can be negative 5. So my limit is negative 5, and then to the right, it can go all the way to infinity. It doesn't matter. So anytime infinity is one of your ends of your domain, you can use a parenthesis. Over here, however, since it's a closed circle, that means I use a bracket. If it was an open circle, I would use a parenthesis, but if it's a closed circle, I use a bracket. So my domain includes negative 5 to positive infinity. That's how you would read that. All right, let's try this example. Okay, 2 questions. Number 1, is it under a radical? Or number 2, is x in the denominator? Okay, in this case, we don't have a radical, but x is in the denominator. So what do? Remember, if it's in the denominator, we need to avoid it being equal to 0, right? So I need to decide, okay, what 2 times x equals 0? What x value is going to make this equal 0? Well, 2 times 0 is going to be 0, right? So 0 is the value I need to avoid in my domain, all right? So that's saying that there is going to be a gap. So on a number line, if here's 0, it can be any number less than 0. It can be any number greater than 0. It just cannot be equal to 0, because that will make my denominator undefined. So I put an open circle there for 0, and I color both ends of my number line, because it can go to negative infinity and to positive infinity. It just cannot include 0. So the way I write this in interval notation, I start with the left-hand boundary, negative infinity, 2. Okay, it comes all the way up to 0, but I put a parenthesis because it does not include 0. If it could include 0, it would be that bracket. Then I jump over that 0. On the other side of 0, I can go to positive infinity. So it has a 2-parter. That shows you that there is a break in the domain of the function. From negative infinity to 0, skip over 0, and then go to positive infinity. That's the way that's notated. All right, number 4. Same 2 questions. Is x under a radical? No. Is x the denominator? Yes. In fact, it's in 2 different denominators, so you have to deal with 2 different scenarios. Okay? In the first case, what's going to make this fraction undefined? Well, if x is 0, I have 1 over 0, so it's undefined, which means I have to avoid that value for x. Over here, x plus 3. What value is going to make that equal to 0? Well, if I put in a negative 3 plus positive 3, that's going to be 0. So the 2 values I need to avoid on my number line are 0, or negative 3, and 0. Okay? I can't have it equal to negative 3 because then I have an undefined fraction here. I can't have it equal to 0 because it's undefined here. So I have to avoid both values. Can it be equal to either value? No, it cannot be equal to either value, because if it is, that makes them undefined. So I have to put open circles. Can it be any other value to the left of negative 3? Could it be any, like negative 4, negative 5, on and on and on? Sure, it can be anything less than negative 3, which means it goes to negative infinity. Could it be a positive, like a negative 1? Would that work? Yeah, negative 1 over negative 1. This would be 1 over 2. That would work. So any value between these two would work. And then lastly, if you pick a point over here, like a positive 1, that would work as well. I would not end up with any undefined fractions. So this portion works. So how do you write this? Well, you got 3 parts to your number line. You're going to have 3 parts to your domain. So it goes from negative infinity to negative 3, parenthesis, because I don't include number 3, or that negative 3. Then I go from negative 3 to 0, parenthesis, because I'm not including the 0. And it jumps over the 0 and goes to positive infinity. Okay? There's my long domain statement in this case. Okay, look at this one. Okay, remember the first question is x in a radical or is x in the denominator? Right? It's not in a radical in this one. It's in the denominator though. So I need to figure out where does this denominator equal 0, right? So I'm going to solve this for x. There's 2 x's here, so I'm going to factor out an x. So I get x minus 2 equals 0. I'm going to set each portion equal to 0 and solve it for x. So if x is 0 or if x is 2, then my denominator equals 0. I cannot have that in my function, so that's where the domain is limited. So on my number line, I have 0 and I have a 2. I cannot have x equal either one of these or my fraction is undefined. So I put open circles. And then can it be any point to the left of 0 all the way to negative infinity? Sure. Anything between 0 and 2, if I put a 1 in there, it would still give me a number. That would work. Anything to the right of positive 2, that would work as well. I just have to skip over those 2 values for x, basically. So in interval notation, I would say from negative infinity to 0, jump over the 0, go all the way up to 2, but don't include the 2, jump over 2, go to positive infinity. There's my domain statement. All right, number 6. This one's got both. Look at that. It's got a radical and an x in the denominator. So you treat them separately. So you say, okay, where is x plus 8 greater than or equal to 0? And then you're going to ask, where is x minus 3 equal to 0? So you have 2 different tests going on. So I'm going to solve this. X is greater than or equal to, if I subtract 8 from both sides, negative 8. And this one said, if I solve it, so x is equal to 3. All right, so let's look at this. On our number line, I need to look at these values, negative 8 and a positive 3. This statement says it could be equal to negative 8, so that means I'm going to have a closed circle. This one, if it equals 3, that's going to make this undefined, so I do not want it to be equal to 3, so I put an open circle. This statement says if x is greater than or equal to negative 8, so I can shade to the right, but I know that 3 cannot be included in my domain, so I have to skip over it and continue on to positive infinity. So when I write my domain, my interval notation, I say this. I can include negative 8, so I put the bracket, negative 8, comma, to 3, but I'm skipping over 3. I'm not including it, so I use a parenthesis. Then I put another parenthesis to show I'm going on the other side of 3 to positive infinity. And I put a parenthesis because infinity is not a definite number. I hope that makes some sense. Now, in your notes, I want you to try this one. To determine the domain of this equation, show your work in your notes, write your answer on the whisk in words. You don't have to use symbols. Remember to do the 2 checks. Is x in a radical? Is x, or is x in the denominator? Do those 2 checks. If you can say no to both, then it's all real numbers. Otherwise, you need to have a domain statement.